Okay, let's go back to here, and then let's go back to continue our discussion. Let's now talk about postcondition. And as I mentioned before, whenever you talk about postcondition, that also include the discussion for invariance, because you can think about invariance for the class is basically the postcondition for every routine. So now, when we say postcondition, we say that let's say Q2 and Q1 and Q2, they are simply just different predicates for the postcondition. We say Q2 ensures more than Q1 if somehow Q2 is stricter or stronger on the outputs. So whenever you talk about postcondition, you're really talking about outputs. And then also, whenever you say stricter or stronger, it allows less output than the other one, right? So now we say that Q2 ensures more than Q1. So whenever you're given two postcondition, you want to know which one is actually stronger, meaning that which one ensures more. You have to, again, try to see if you can establish the implication relation between the two predicates. We'll see example in just a moment. Okay, so this will be the formal relation. You want to say the set of satisfying value for Q2 is a subset of the set of satisfying value for Q1. In this case, if you can prove it or demonstrate it, in that case, Q2 will be said to be the stronger one, which means Q2 ensures more. Okay, so you want to know, in the previous slides, we want to know, having two predicates as the preconditions, which one ensure less and which one which one require less versus which one requires more. And now, given two predicates for the postcondition, we want to know which one ensures more and which one ensures less, right? But to really, the guiding principle is the same. You want to establish the subset relation or implication, either way, right? You can see, think about this subset relation here will be easily, can be more conveniently demonstrated if you draw diagrams. And this one over here, just to prove which one can implies which. All right, let's see one example over here. Let's say we simply got a query Q, which will take an integer value, and then it's going to return output value Boolean. Okay, and now let's consider two postconditions. One is the result, the Boolean is simply if and only if, let's say I larger than 0 and I modulo 2 equals 0. Basically, we're saying that result will be true if and only if the input I is a positive even number. All right, and now let's say for Q1, which is an alternative postcondition, this one saying that result is actually true if and only if either because I is positive, in that case I can even be an odd number, or I is basically is an even number but it can be negative, right? You can see the difference between conjunction and disjunction. Just as a first example, I want to make it very clear to you. So now how do we decide which postcondition ensures more, right? Let's now go back to iPad over here, and now let's talk about these two postconditions very quickly. We already, which one should be stronger? And you learn from 1090 that given any predicates, you know that, let's say P2 and, let me just let me not use P2 and P1. Let me just say X and Y. How about that? Let's just say, yeah, X and Y. If I got two predicates, X and Y, X and Y always always implies X or Y. So this is something I assume you know already from the previous logic course, right? I'm not gonna bother you with that. If you want to prove it, the easiest way to prove it is by using a truth table. If you're interested in reviewing this, I can come to me. All right. So now we want to think about for Q1 and Q2. Apparently, you can think about this part over here is X, and this part over here is Y, right? This part here is X, and this part here is actually Y. So now apparently you can see one is conjunction, and the other one is disjunction. And it's quite obvious Q1 implies Q2 implies Q1. So now if you think about this is, so this Q2 having conjunction, and this is actually Q1 having disjunction. So we know very well over here, so Q2 versus Q1. And then we know that it should be this relation over here, right? And now let's think about how do you visualize this as a subset relation. Think about over here, if I got Q1 over here, oh, sorry, let me just draw a little bit better. Let's say this is Q1. Apparently, it's going to be a larger set, and this is Q2. So now, what can be the values over here, right? You can see now, to really visualize this is slightly trickier than if you simply just want to see what's the extra value for larger than 0 versus larger than or equal to 0, right? This one is kind of more interesting. Apparently, well, I already actually said that when I first introduced these two predicates. Let's think about it. For Q1, apparently, you can allow something that's positive but not even. For example, if you think about 79, right? It's actually one of the input value I put over here. 79 will actually satisfy in Q1, but not Q2. It's not in Q2 because it's not even, right? Similarly, if I say minus 34, for example, over here, minus 34 is actually an even number over here. It's satisfying the right-hand side for the disjunction. However, even though it does not satisfy being positive, that's okay because it's disjunction, so that's fine. So that's why minus 34 is going to satisfy Q1 but not Q2. All right. So these are just two example values that's actually in Q1 but not in Q2. All right. So now let's now think about a little bit more to see why we would say that the stronger predicate over here is going to ensure more. In some way, it's harder to output values that's actually going to satisfy Q2. That's what we meant by ensure more. And why Q1 will ensure less? Let's see exactly how. I'm just going to use the 3 input values I just put over here. Okay, just over here. And let's now do a similar exercise as we did before. And now let's say this. We got F1 and F2, right? So now why don't we say F1? F1, 79. And also we got also F1 minus 34. And also we got F1 calling 62. By the way, so now our interest is not really in the precondition. Implicitly, for both F1 and F2, there's precondition is simply just true. Let's assume that's the case, right? So now so every one of them will be a valid call. There will not be any precondition violation. Let's now also apply the similar call to F2. Okay, so now let's see F2. F2 79. And also F2 minus 34, and also F2 62. So now, how do we actually see why this particular postcondition over here is ensuring more, whereas this particular postcondition by contrast is ensuring less? Let's see that. So this is a question we want to ask ourselves. Let me write it down before we actually try to see each one of them. So what would be, what's the value of result? What's the value of result that will satisfy the postcondition? So this is really the guiding question for us to see the illustration. So what's the value of the result? And let me remind you, it's really about output. So whenever we talk about postcondition, we are really concerning about the output values. Let's see this. So now for F1, if we are calling 79, we know that 79 is going to make this particular predicate on the right-hand side true, right? Whenever I talk about this entire disjunction over here, we know very well it's going to be true. So now the result has to be true in order to satisfy the postcondition, right? I'm kind of thinking about, given the postcondition, what should be the output value be so that it will satisfy the postcondition? I'm thinking like a backwards because now I'm only considering design rather than diving into the implementation details. What about the second one? Minus 34, I know that is also going to be true for the right hand side. So now what should be the corresponding result value? Well, it should be also true. So now what about 62? Well, 62 is also going to be true, right? The result will just be true. You can see in some way the result conceptually is actually easier to do because for each of these input categories, you can simply just return true, right? It's kind of ensuring less. Okay, let's now see the F2 cases, right? So now I think about what should be the value for the right hand side over here. Once we know either that should be true or false, we would know what the corresponding result value should be. So now in the case for 79, you can see 79 is actually going to satisfy this part over here, but it does not satisfy this part. So overall, it's going to be false. So the result value should be false. So what about the second one? Minus 34 is not going to satisfy this one here, even though it satisfies the right-hand side of the conjunction. So overall, it's still going to be false. So that means the result has to be false. That's why I put false over here. So what about 62? 62 apparently is going to satisfy both sides over here, right? It's both positive and also even. So that means it's going to be true. And now for the result value, it should be set to be true in order not to have a postcondition violation. Alright, so now you might be wondering why with such illustration for the 3 input values and with the different result value between the 2 versions of the postcondition, why would this illustrate that one is ensuring more than the other? Let me just visualize once more from another angle for you. So think about what we're having here is, let's think about this will be the entire space for the input value. The input, which is I, right? Can think about for both versions of the routine is really taking I, right? And then we are really talking about 2 conditions over here, just for this particular example. I larger than 0 versus I modulo 2 equals 0. So let's draw the diagram over here. You can think about this is one state space. So this is just another state space for the input value. So you can think about this part here is I larger than 0. This part is I modulo 2 equals 0, which means the number is actually even, right? So the 3 example values for the input that we just illustrated belong to different categories over here, basically, right? So now you can think about for 79, it's actually over here. It's positive, but not even. And also for minus 34, it's actually even, but not positive. And also we got also 62 is actually in both cases. Of course, you can also put another value over here. For example, you can put maybe minus 33. It's neither positive nor even, right? So I just didn't have that, but you can see that example implicitly as well. So now let's think about what's happening over here. In this case, in the case for Q1 over here, for Q1, I'm going to use green. Q1 is saying that in order for the postcondition to be satisfied, so result must be done in this way. So now let's see this. It should be disjunction. So it's more like a union. So you can think about this is basically Q1, right? It's going to be the union for both states, for both predicates. So that's Q1. In order for Q1 to be satisfied, the result has to make sure it return true actually for all the value that's in this particular range, right? Result has to be true. On the other hand, if you think about for Q2, so for Q2 over here, so now let me use pink. So Q2, since it's using conjunction, so now in order to satisfy Q2, the result can be set to true only if the input is actually in this particular range over here, only 62, right? You can see this is a strictly smaller space over here, and because the satisfying value is actually strictly smaller, that means it's actually stronger, right? So now you can see that, okay, think about this is basically Q2. Okay, so let me just so this will be the satisfying value for Q2. So that means, so this is ensure more about the output value, which is result. In some way, it's harder to, it's really harder, let me just put it in quotes, right? Conceptually, it's actually harder to satisfy the postcondition. In the sense that in order to satisfy Q2, you want to make sure, in this case, only this, okay, let me illustrate to you. Why is it harder to satisfy Q2? Because in order to satisfy Q2, you want to make sure only this range of the input value you're going to return true, but all the others over here, you're going to return false. Versus in the case of a Q1, it's actually much easier to satisfy because you can simply say, well, whenever I got any input value that's in this particular strictly larger set, I will simply just give you true. So it's actually much easier to actually satisfy, right? So don't be too worried about getting the complete intuition about this particular example. I'm trying to do as much as I can, the best I could. But I think when we talk about logic over here, so you really want to think about this particular post condition logically is weaker than this post condition over here, because we can justify the implication. But exactly how the intuition should really go, I think that's basically what you want to think about when you want to justify it. But we're going to see more examples about strengthening the post condition in the case of inheritance. We'll see that in a moment. All right, so now let's go back to the slides to finish off the discussion for post condition. So final question. So now, having discussed about the post condition here, either ensuring less or ensuring more. So what would be the post condition that ensures the most? So what would be that one? Well, so basically you want to be, the more the post condition can ensure, the harder it is to actually satisfy the post condition. Think about, if the post condition ensures more, it's actually harder for the supplier, for the implementation to really satisfy it. So now, what would be the hardest predicates in order for the supplier to satisfy for their implementation? What would be the hardest one? Well, the hardest one would be maybe something that will always be dissatisfied. That means the peakiest post condition. Well, it should be false. Think about what's the set of satisfying value for false. It would just be the empty set, right? And then you learn very well from the 1090. The strongest would be simply just false, right? And then we know that, so the set of satisfying value for the false would just be empty set. And we know that the empty set is always a subset of any set. So that means any predicates you give as the alternative, there will always be weaker than the empty set. Well, it will always be like a superset for the empty set, right? So now that means this one will be the post condition logically that will ensure the most, which means this will be the hardest one for you to satisfy. In that case, that will be the predicate for false. All right. Okay, so that's about the background about logic. It's quite a bit of discussion over here. Maybe may not be hard logically, but I just want to draw the connection between logic and also the design by contract that we talk about. Okay, so make sure you review the ideas about stronger versus weaker, and also ensure less versus ensure more, and also require less versus require more before you move on to the more discussion about the subcontracting.